Let's go over these 5 problems. And as we go over these 5 problems, I want you to make sure that you know your job. Your job is not only picking the right answer. You must critically look at the other answer choices and prove how they are incorrect. If you just pick the right answer and did not reject the other answers, then you could still be wrong. Okay? I want to make sure that we are all clear about our job right here. So first up, let's take a look at our the electron spectroscopy diagram right here. So now I want to just remind everyone here that this diagram is a little bit atypical because the way that our horizontal axis it's designed or arranged, because usually we have the small number on the left and big number on the right. So this is like flipped, and you may think about why flipped? Why flipped? Okay. Well, let me go ahead and draw something that could well explain why it is flipped. I'm going to draw this. Okay. What is this? I'm going to label this as the nucleus. Okay. And that's how we know the electron configuration. 1s2, 2s1. Okay. And by the way, the height of the peak, it's representing the amount of electrons. Okay, so that's how we know that first one right there is 1s2. And you know it's 1s2 because it's the closest, or they are the closest electrons to the nucleus, and they must have the highest energy to remove them. Okay, and subsequently, anything that's farther away from the nucleus, it would require lesser amount of energy to remove them. Okay, so which one is the 1s electron? It is going to be X, all right, because we understand how to read this picture. And why is it X? There are 2 possible explanations. And it would not be A because it's not the easiest to remove from the atom. It's the hardest. So now you know why B is the answer. Okay, so make sure you know this is the strategy, and this will be the strategy as you go toward your AP exam. Okay, number two. The photospectrum, the photoelectron spectrum for the element boron is represented. So I can see how it is 1s2, 2s2, 2p1, right? Atomic number 5, 5 total electrons. Which of the following best explains how the spectrum is consistent with the electron shell model of the atom? A, it shows odd number electrons. Looks pretty good. The spectrum shows a single electron in the 2p subshell. Looks pretty good. C, the spectrum shows equal number of electrons in the first and second electron shell. That's not good. And D, the spectrum shows the electron with the same binding energy in the second. Well, not the same. They're different. So now, which of the following best explains how the spectrum is consistent with the electron shell model of the atom? So, did you pick one? Or did you pick A or did you pick B? B? Yes. The spectrum shows a single electron in a 2p subshell. That is the reason why it is boron. If you just say it's an odd number electrons, then I would say a little bit too vague in this case. Number 3, by the way, there's a little typo right here. Just ignore that little I right there. Same thing right here. We have carbon. Okay, so if you want to write down the electron configuration, you could. Okay, 1s2, 2s2, 2p2. And which of the following explains the spectrum? It's consistent with the electron shell model of the atom. That would be A, it's not correct. There won't be 4 electrons in the inner electron shell. It would be an outer electron shell. So that is not correct. B, the spectrum shows equal number of electrons in 3 occupied electron subshell. Sounds pretty good. See, the spectrum shows that all electrons in the valence shell have the same binding energy. That it's not correct. We have two different peaks right here. They're different in terms of binding energy. Which one? See, the spectrum shows that all the electrons in the valence shell, that means in the second energy level, not the sublevel, but the second energy level, they have the same binding energy, meaning that they have the same location for the peaks. I mean, they're not the same. There are two different peaks. That means there are two different binding energies. Now, so this is where you have to be very careful. When we say valence shell, we're talking about the first shell, second shell, third shell, fourth shell. When you say SPDF, we're talking about the subshell or the type of orbitals. The type, okay? Not even the orbital, okay? Like P is a subshell, and there are 3 orbitals in the P sublevel or subshell. Okay, so make sure you have a clear hierarchy of these terms. D, the spectrum shows more electrons in the inner energy shell, which is the first one, than the outer electron shell. That it's not possible because the first shell it has only 2 electrons, and the second shell they got 4. So B is the answer. Okay. Yeah, it's time consuming, but you need to really scan through the choices, underline what goes wrong, cross them out so that you can clearly confirm yourself that you've got the right answer. All right, now you've got some elements right here. What do we see here? These elements are all in group 15. Okay, group 15. The atomic radii of the elements in the nitrogen group in the periodic table are given in the table above. Which of the following best helps explain the trend of increasing atomic radius? Okay, now one thing that I want to make sure that you are fully aware of what's about to happen. There could be factual statements that may not help explain. Okay, but I could put a statement right there and says Mr. Chan is a teacher. It's true, but it does not help explain the situation right here. So make sure you know what it's coming your way. It says, okay, A, the number of particles in the nucleus of the atom increases. It is factual, but it's not the explanation. Okay, or actually you should know why the atomic radii will increase from nitrogen to bismuth because of the increasing distance or energy levels, right? Yes, there are more protons, but that's not the reason. Okay, it is the energy levels. So now you have a little answer, okay, hovering over your head. You know what to anticipate, and now you go ahead and anticipate. B, the number of electrons in the outermost shell of the atom increases. No, because the number of electrons in the outermost shell, they stay at 5. Since it's group 15, they all have 5 valence electrons. C, the attractive force between the valence shell, valence electrons and the nuclei of the atom decreases. Ooh, that looks good. Because we have more distance, more energy level, more shielding effect, if you remember. And D, the repulsive force between the valence electrons and the electrons in the inner shell decreases. That is actually false because with more and more electrons, more energy levels, the repulsion actually increases. Okay? Actually increases. So that's why C is the correct statement. Okay? A is a factual statement that does not explain it. C is the factual statement and explains it. Good. Last but not least, which of the following best explains or best helps to explain why the atomic radius of K, it's potassium, is greater than bromine? The atomic radius of K, it's more than bromine. So before we look at these answer choices, I hope you knew the answer already. What's the answer? What's the reason why potassium is bigger than bromine? They're in the same period. How come potassium is bigger than bromine atom? Louder. Now, you will not, I will not use ionization energy to explain it. Because ionization energy is like a consequence of something more fundamental. Okay? Like how big basically you can interpret that as how big the size of an atom. How come potassium is bigger than bromine? So what do we say? As we go from left to right, in the same period, what changes? The number of what? Electrons, yes, increases. Protons also increases, but it's really the protons. Because they have same number of electron shells, but we've got more protons, and therefore we have more effective nuclear charge on the right-hand side. So, and by the way, A is not even a factual statement. The first ionization energy is higher in bromine than potassium. Ionization energy is the energy required to remove an electron. The first ionization energy is the energy required to remove the first electron. And because the attraction becomes stronger to the right within a period, so, well, stronger means it's going to get closer. Stronger attraction. With stronger attraction, it's going to be harder to remove the electron. Okay, so that's why A is not the correct choice. B, the valence electrons in K are in higher principal energy level than Br. Well, that will be true if someone does not read the periodic table. In the same period, the valence electrons are in the same principal energy level. C, in the ground state, an atom of K has fewer unpaired electrons than an atom of bromine has. Actually, if you actually look at the electron configuration, like the orbital diagram, they both have one unpaired electrons, and that is not even the reason. So it's D. The effective nuclear charge experienced by the valence electrons is smaller for K than for bromine because the effective nuclear charge for K is 1, the effective nuclear charge for bromine is 7, and these two numbers are exactly the same as the number of valence electrons, if you don't know it yet. When we talk about effective nuclear charge for these elements, for the main group elements, that number for an effective nuclear charge is the same number for valence electrons. So that's why we say as we go to the right on the periodic table, in the same period, the effective nuclear charge increases.